Welcome back to Let's Code Games. This is the second video in our racing series, and in this episode you will learn how to set up your scene so it has colliders, so your car can crash into things. And we're going to talk about triggers and colliders and what's the difference between those. And we're going to make our car slip on some oil spills. So let's jump right in. So last episode we made our car move. We can turn, we can move forward and backwards and stuff like that. But as you can see here, we don't collide with anything. We can move off the track, we can run over obstacles. So that's what we're going to do now. So we select our obstacles in the center of the track first, and we set up a collider. This is a box collider 2D since we're using 2D physics. And basically what this says is that we have a box and the physics object should collide with that. Since our car has a rigid body and a collider already set up to it, whenever there's just a collider in the scene without any rigid bodies, it just views that as a static obstacle, something that you can't move past at all costs. So we have to set up the whole track like that. It's super simple, and we use a couple of different colliders. Here, for example, we use circle colliders because they approximate the shape of the barrels very well. And we use some more box colliders. There are plenty of different colliders you can use, and they have some different performance considerations. For example, a Polygon Collider, which we will be using here, is a little bit more expensive to calculate than a box collider or a circle collider. But PCs nowadays are so powerful that you shouldn't really concern yourself with performance on the get-go. Just throw everything in there and see if it runs, and then later you can see if it's a little slow, where you can optimize. And especially with colliders and stuff, if you set up a few colliders, it doesn't matter at all. You can set up hundreds and thousands of colliders, and Unity will take care of that for you without any problems. So for the rock shapes here, they are a little bit more complicated. So a simple collider like a box or a circle collider doesn't really work well. So we use the Polygon Collider. The cool part about the Polygon Collider is that we can design each individual vertex and position it where we want. So we can make an approximate shape of the object that we want really well. Especially with something like this, which is very jaggy and stuff like that. When you apply a Polygon Collider, Unity first tries to approximate the shape that's already there. It takes the sprite renderer that's on the same component and analyzes it and sees if it can make an approximation of the shape that the sprite has. So you already start up with a very kind of useful shape. But it's not perfect. It has some boundary issues. Sometimes it goes a little bit over and stuff like that. So you can very easily adjust it by clicking the Edit Collider button in the top of the Polygon Collider component. And then you can simply click and drag the vertices around. So just by moving your mouse to the vertices, they light up, and then you can move them by clicking and dragging. And by shift clicking something, you can see sometimes here, for example, the line becomes red, and that means shift clicking means you remove a vertex. And it just highlights you which line is being affected by that. When you hold shift down, it shows that in red. Yeah, so Polygon colliders are very useful for complex shapes to approximate that. So we've been using box colliders and circle colliders now. Apart from that, there are a couple more. We have more a capsule collider, for example, which is basically a circle with a square in the middle, so like a half circle on top, half circle on bottom, and then elongated. And we have stuff like compound colliders where you can combine colliders and stuff like that. But we don't really use those here. We basically just have box, circle, and polygon colliders. And now when we drive around, you can see that we can collide with everything. And yeah, and it's really as simple as that. And now we have collision in our track. What we notice here, though, is that the response to the collision is not really all that gamey, all that interesting. So we simply drive into the obstacle and then drive, and the force will be applied continuously. So the car just kind of sticks to the obstacles. And for a game like this, which is kind of arcadey, a little bit like Micro Machines, for example. We want something more snappy, more bouncy. So we use something called a physics material. A physics material is something that you can apply to your colliders or your rigid body, and it has some properties that the physics engine use. In this case, for 2D stuff, it has the bounciness and the friction. So you can change these and play with these to get a feel that's more to something that you really want to have. Friction is not something that we use right now because we're not sliding across stuff, but we want to use the bounciness. So when we crash into an object, we want to bounce back a little bit, just to have that crash a little bit of to make it to have a visual impact of that crash. So we're using a bounciness of 2 here, so the bounce back is a little stronger than what we came in for, and it already feels a little bit better. So the next thing that we want to set up is that when we crash into stuff, we want to handle it in a specific way. And for this, Unity has a very useful concept called tags. And tags, you can attach one tag to each game object, and they make searching and identifying objects very, very simple. So here I set up an obstacle tag and applied the obstacle tag to all the colliders of the level environment. So all the trees, or the barrels and stuff like that. And they all have an obstacle tag. And what we can do now is we create a component called car collision, and we set up the callback on collision enter 2D. That's a magic function, just like start or awake or update by Unity, that's being called if something specific happens. In this case, when a 2D collision happens, Unity checks all components, sees if they have a on collision to enter 2D method, and if they have that method, Unity just calls it. So in this case, we want to start out by just like giving a debug log and seeing what happens, what we collide with, getting the name and the tag of the objects that we collide with. So here we're colliding with a tribune, and it's an obstacle, and yeah, we can see with the different objects that we collide with. So we get that callback back, which is very useful. So now that we have that callback, we can start dealing with it. We can start making something happen. And I still don't really like the bounce back, because the car just continues to drive forward. So what I have in mind is to talk to the movement component of the car, and so we get a reference to that, just like always. We just save that reference in the awake method once, so we have that reference throughout the game. And in my movement component, I define a function called onCollideWithObstacle. So that's being called whenever I collide with a static obstacle in a scene. And that's not being called automatically. That's a custom function by us. So we need to make sure that this happens. So in our onCollisionEnterToD method, we check, does the collision, the object that we collide with, has it a tag obstacle? And if yes, then we call that function onCollisionWithObstacle. And so you can see that the tags are useful, so you can separate out behavior. When you collide with an obstacle, might be different when you collide with an oil spill or a different car, for example. So you can use tags to separate those paths. So what we want to do next is, when we collide with an obstacle, we want to cut the engine off. We collide with the obstacle, we bounce back and use all that bounce back force, and then we basically stay where we are because the engine was cut off, and then we can start to accelerate back from that, which is a nice behavior for this kind of game that we want to have here. So that's what happens when we collide with an obstacle. So let's make sure that we have some different obstacles in there that have different behavior. So I'm using the oil spill visuals here and setting it up so we have an oil obstacle. And what I want to do with the oil obstacle is, once we collide with that, I want to make the car spin out of control, just like in Mario Kart, and you have to you stop for a while until you can drive further. So we're setting up the oil spill, so it has a Polygon Collider, and for game objects like this, when there are obstacles and stuff, I always like to make the collider smaller than the actual object, because this gives the player the feeling sometimes when they almost hit, but when they really have hit the object, but but only the edge of it, they get the feeling of getting away with it, which is a nice feeling for the character. And I think I could have even made this a little bit smaller, because that's a very positive feeling for the player when they just like almost hit, but they kind of get away with it. It's always a good feeling. So let's make a proper object from that oil spill. So again, I set up a visuals game object as a child just to get into that habit, of doing that. And I make sure that all the child objects are in the center of the root object. So we have the oil component. We add a new tag now. Make sure that we can know that we've collided with the oil. And that's about it. We have set up our collider and we've set up the tag. But we want to do something a little bit different here as well. So the oil spill, while we want to collide with it, we don't want to it shouldn't be an obstacle that you bounce back from, right? You should be able to move through it, and we just want to have something happen. And you can do that by using triggers. And triggers are exactly the same as colliders. In fact, it's the same component as the collider. There's just a checkbox that you mark this as a trigger. And the difference is, though, that you get a different callback. It's on Ontriggerenter 2D now, so you have to set that up. And it has slightly different parameter. In Ontriggerenter, you just get the collider you're colliding with, and in OnCollisionEnter, you get a collision object, which gives you more data, how you collide and stuff like that, and how you bounce back. But for this is just a trigger. So we're setting up the isTrigger button, making sure that this is an oil, and when we press play, and there's the regular obstacle, but when we move through here, you can see we're colliding with it and we're slowing down, but we can still move past it. And that's the difference between a trigger and a collider. A collider is a physical obstacle you can pass through, and a trigger is just gives you that callback. It tells you, hey, I've collided with it, but it doesn't do anything to the physics object. It doesn't stop it or stuff like that. So you can imagine you can use that for collectibles like coins, stuff like that, where you pick something up, but you don't really want to be slowed down by the object that you're picking up. Okay, so we're slowing down from the oil spill, which is very nice, but we can still move past it, so it's an interesting obstacle on the road. But the other thing that we want to do here is when we go off course, when we're not on the asphalt of the racetrack, but on the dirt or on the grass, we want to have some response to that, so that the player is encouraged to stick to the road. To be able to do that, we set up different colliders again, and we make sure, so now we're setting up a box collider for this center area, just because it happens to be a box shape, so we can use that. And we just mark that out so we know where it is and we can work with it. And again, we want to work with the trigger here because we want to still be able to move past it when we just want to have some different behavior. I actually forgot to set the trigger here, which is often what happens. So in a second, when we test this code here, you'll see that I crash in this. But we set up another tag so that we can identify that we collided with the off course area, and then we can do stuff. And you can see here we have another method coming in now, which is the onTriggerExit. So Unity gives you different callbacks for physics. So we have onCollisionEnter and onTriggerEnter. These are the two that we used before. And now we start to use onTriggerExit, which basically gets called once you move out of that trigger zone again. So this is very useful for this zone because we know that are we in a zone or are we outside a zone? And we can, in this case, if we enter the area, we make sure that the maximum engine power is reduced to like 50% of the maximum force, so the car moves slower on the outside area. And when we exit that trigger again, we set the engine force back to maximum so we can move as fast as possible. So let's see how that works. And you can see here, oh, I forgot to set up the trigger. So I go back into the course, check the trigger box, and then press play again. And you can see now when I'm off the course, the car is moving slower. And when I get back on the track, we get the full power again and can move fast again. Yeah, so the Ontriggerenter and Ontriggerexit methods are very useful for that. You have the same for colliders, so OnColliderEnter, OnCollisionEnter, and OnCollisionExit. So when the collision starts and when the collision stops, that's sometimes useful to use. And you also have a third callback called OnCollisionStay or OnTriggerStay. And that's being called every frame the collision happens. So OnTriggerEnter and OnTriggerExit are only called once, when you enter and when you exit, and OnTriggerStay is called as long as you're in that zone. So we could use the off-screen area, we could use that in two different ways. We could either do like we did here, like OnTriggerEnter and OnTriggerExit to see if we're in the zone or not. Or we could use OnTriggerStay, and then whenever we're staying in that zone, we just make sure the engine is being cut back. So there are different ways that you can achieve the same effect with, and that's always the case in Unity. There are so many different ways to do anything. You just have to find one way that works for you and for your game. And one of my teachers told me that a game or a code is efficient when it does what it's supposed to do. So just try to make it work, and then you have good code. And then if you later see that's not performance and you need to optimize it, then you can optimize it later. So don't fall into the trap of optimizing while you write your code. Make sure that you can write as quickly as possible. Because the most expensive thing really is your programming time at this point. We have so much CPU, so much RAM and stuff like that. So the most expensive resource is programmer time. So optimize for that first. Make sure you get to results as quickly as possible, and later make sure that if the game doesn't run properly, then you can optimize your code. So we set up another collider for the outside zone. I used the Polygon Collider to define the outside zone there. So now whenever we drive off outside or inside, our car gets slowed down. And that's working rather nicely. So the next thing that we want to implement is some sort of spinning mechanics. So when the car moves into the oil spill, we actually want to have some visual feedback for that, and it's spinning out of control just like in Mario Kart. So what we're doing here is we're setting up something called a coroutine, and coroutines are super useful in Unity, and they basically allow you to have code execute at different times, and you can then pause that code because it runs in parallel to your main code. So you have a main code running, you have a coroutine on the side, and since the coroutine is on the side, you can do stuff like wait for a second before you continue and stuff like that. So coroutines are very useful to have code running side by side. Yeah, so we set up different variables for our spinning, like how fast we want to spin, how long we want to spin, and then in the coroutine we have this is spinning variable, so we know that we're spinning. So this we can use later so that we don't spin like multiple times when we for some reason stay on the oil spill when we spin out of control. Okay, so first of all, like in the coroutine, it works a little bit different. Basically, what we do is we write our own update function, which we do here in this while method. So while the spinning time is smaller than the spinning duration, we want to do something. And then we increase the spinning time every frame by time delta time, which is the time passed since the last frame. So we have our own time counter that slowly goes up until it reaches spinning duration, and then we get out of that while loop. But as you notice here, we're kind of writing a while loop that basically just blocks the code for the spinning duration, right? Because it's a while loop, so it runs all the time until the spinning time is complete. So that's why we use yield return null here. And yield is basically the magic of the coroutines. Yield means wait for something. And in this case, we don't want to wait for anything, which in Unity terms means we are waiting 1 frame. So we're yielding for 1 frame and then starting over again. So what we did here is we write another update method that runs in parallel to the existing update method that we have. And then we can have a method like this, like start spinning, and we can check if we are already spinning. And if we are, we don't want to spin again. So this is just a little check here. And we start a coroutine by calling start coroutine and then passing on the coroutine method. So when we collide with the oil, we want to start spinning, and what we also want to do is while we're spinning, we want to cut off the engine power. So while we're spinning, we cannot move forward. So this is like an even worse obstacle than driving off the road and stuff like that. So because we're in place for a couple seconds or couple tenths of seconds. So let's see how that works. We're setting up the values here. That's spinning duration, like a half a second, and we want to turn over 3 times. And what you see here, I forgot to set up the reference visual parent, and that's where the hierarchy that we set up in the beginning with the visuals parent comes in handy really well. Because what we can do here, we can actually spin the visuals parent, and so we get a great feedback of the car spinning, but it doesn't change the physics engine or the model itself. It's basically just a visual effect. And by having the visuals component separate from the actual physics object like that, we can create these effects very safely without affecting the rest of the game. So you can see here, when we collide, we spin the visuals parent, the collider stays in place actually. So we're kind of faking it, the spinning a little bit. Yeah. But it works really well. We want to set up some of the values, like it turns a little fast, and it also turns in the wrong direction. So so we play around with those values a little bit, make it look awesome and feel awesome, and then we set some more oil spills on the rest of the track, and that's pretty much it. Now we set up a collision with an oil spill, but it's actually a trigger, so we can move past it, but something is happening, and we have some nice visual feedback there. Yeah, so that's it for this episode. We really would like to have your feedback, what you like about this format, if you don't like it, what you want to see from this channel, because we want to do more videos like these. And next week we want to finish off this racing series by having some time tracking mechanics in there, so we can run against ourselves, have a best time, and to see who is the fastest on this track and stuff like that. So we have a more complete racing game. Okay, so thanks for watching. I hope you enjoyed this, and I'll see you next week again.